Hey, Andreas, I'm going to log off and log back in, okay, with the OCP credentials.
Hey, Boppy, how you doing?
Good, how are you? Hey, I'm going to log out and log back in with OCP credentials, okay? Otherwise, I can't manage if there's somebody not on mute, etc.
Okay, should I stay on or log out?
Oh, you should stay on.
Okay, all right.
All right. So we'll give it a few minutes to build up a quorum. Andreas, you want to test your screen sharing, etc., while we're waiting?
Yeah, I can do that.
There's a lot of interest, so we're all good. And next week, while Andreas is getting set up, Marek will run the meeting since I will be on the road. We don't have a meeting on 11/24. And then there's an interesting meeting on January 12th. Steve Helvey is going to present on the OCP marketplace. So if you'd like a product that's going to be that you want listed, and so Andreas, this might be interesting to you too. If you'd like a product that you want to be listed in the marketplace, at least he'll start with that. And the intent is to kick off a sequence of discussions on how we get chiplets or chiplet related products onto the marketplace. So 112, Steve Helvey will just come in and present what the marketplace is, and then we will form a plan based on what all of you think over the next few weeks. Okay. Yep, I can see the slides. I'm assuming everybody can. Let me see. Oh yeah. Andreas, it's all yours. We've got more than enough to get started and everything else.
Okay, all right, great. So I'm gonna present some work we've done on our internal protocol for quite a while now. So this is I've got, most of my team is here with me on the call. First time here, right? So it's me, Andreas, and then Stephen Herbst, Damir Volk, Edgar Iglesias, and Wenting Zhang, and Ali Zaidi. And so let me just dig in, right? So those of you who don't know us or me, so we have a startup in Boston, or really spread throughout North America and Europe, called Eurasic. We're a chip company. So our business model is to design and sell custom ASICs, or system in packages based on chiplets. And we're working on a bunch of technology. We have our own FPGA, our own CPU, machine learning accelerator. We've got CAD infrastructure, emulation, and chiplets. So I've been talking about this for a long time, and I'm starting to feel like a broken record by going all the way back to DARPA. My view is that at below a picojoule per bit, there's no room for errors, right? There's no adapters, there's no rerouters or substrate. You need to complete the stack and really standardize everything. We'll see if I'm right on this, but you don't have to reroute something very far or put a conductor in to ruin a 0.1 picojoule per bit type performance on a wire, or ruin a 32 gigabits per second signal rate, right? It's very, very precise. So if you look at USB, PCIe, or Ethernet, right, there have been physical standards, some more successful than others. Mistakes have been made, but any non-compatibility is painful. So the way I see it, there's kind of this is a rough 3-level stack, right? Mechanical, electrical, protocol. Let's not get caught up into exactly how many layers there are, but roughly this is the way I see it. By the way, let's can make this a conversation. So any interruptions or comments, please feel free. So if we look at the chiplet stack status today, there's it's fairly there's definitely been a lot of work done in the last 6-7 years, but there hasn't been really a protocol cemented like we have in SoCs, where there used to be a lot of on-chip protocols, but then AXI or AMBA kind of became the default, and everybody rallied and created their IPs around AMBA. We don't have that yet for chiplets, right? We have a few electrical protocols, and definitely the winners seem to be coming out, but we really don't have mechanical protocols. So except for HBM, right? Of course, which is fairly rigidly defined. So my view is that we want to try to complete the stack. So our goal is to create a complete and open chiplet stack. So mechanical, electrical, and protocol. That means that on the protocol side, we want to have how do you order the bits, right? What is the information you're passing, right? Bit packing and ordering. Electrical, right? How do you pass the electrons back and forth, right? How many wires, kind of leveling and so forth. And then what do the footprints actually look like? Can we have standardized footprints like HBM has? So we have a plan laid out for all of this. So today I'm going to talk only about the UMI. I'm happy to talk in the future about any of the other components. So I've had this argument with many people over the years about why protocols are important. So this is my view. And when you talk about high performance, you can usually translate things if you're willing to give up on performance or energy. But if you care about performance and energy, you need to have a complete agreement between TX and RX, right? So if you start on the left side, if you have a load store in a CPU, for example, generating basically a read-write, it doesn't come out as an AXI transaction or a CXL transaction. It comes out as an opcode, and comes out of the inter-ALU as an address, right? And you have a data field coming out of the register file that has to go to memory somewhere, let's say, right? Or and from that, you're going to convert that into some structure, right? Could be AXI or something else. And then you get that information structure, that's going to be able to carry through the network. And you put that into a PHY, and then you compress that into something that's applicable to maybe a chip, right? That has a certain number of wires. And then whoever's receiving that on the other end has to replay that in reverse, right? All those steps. And if you don't get it right, it's just garbage, right? You won't be able to decode it. And so before you get to the memory, right? So that's where the protocol comes in. So I at DARPA, I tried to push this hard, and I kind of failed. People kind of settled on sort of, let's do just a streaming protocol. Let's have maybe a valid signal and data bits, and we'll let the receiver and transmitter figure it out. And what ends up happening, you get n transmitters, and then you need n receivers that are hard coded for that, or a universal translator, which becomes an n squared translation problem. So much better if we can just all agree on a protocol standard and be done with it. I like to say that the streaming protocols are the non-standard standards. So I've tracked it. There might be others, and if I miss something, happy to know. But I've tracked two efforts. One is by the AIB group, AIB protocols, that have done an effort of serializing AXI. And some years back, I saw there was the DIPort from NXP, which also was I didn't see code for that, but I saw the presentation that tried to serialize AXI. And my problem with AXI is that it's a bus protocol. It's not packet native, so we know that buses don't scale well. So I think 2023, it's not a good starting point. We need to think about packets, and we need to think about chiplets and constraints around chiplets. So I'm not a fan of saying that AXI should be the native protocol. It's okay to do translators, but not as a native protocol.
So, Andreas, just one minor quibble. We do have a transaction and link layer protocol in the ODSA. It's been there for about, I guess, a year and change now. Okay. And non-AXI, just a packetization mechanism.
Yeah, I knew that. We looked at it. I should have put it here as well. Sorry. Yeah, you're right.
No worries.
Yeah. So why do we need a new protocol when there are so many protocols out there, right? Like it's like that joke, right? We need one more standard. So now we have n+1 standards. And I think the question is, okay, why aren't the existing things good enough? And so again, there's more standards than what I have here, but when we look at the major ones that we looked at here, like AXI, TIE-Link, or CXL, there were reasons, right? I talked a little bit about AXI, about how AXI itself is not appropriate for chiplets. It's got too many wires, too many channels. It doesn't serialize very effectively, and so we decided that we want to go packet native instead of trying to do AXI as the native protocol. TIE-Link doesn't seem to have picked up a lot, so that may not be a good avenue to go. And then CXL for embedded devices just seems too heavyweight. But if you're doing UCIe, with CXL being one of the standards, that makes sense. But for some of the things we're doing for embedded, it's just too heavyweight.
Andreas, in this context, what do you mean by channels?
Independent non-blocking channels, right? So it could be a physical channel, or it could be a virtual channel, but it's
okay.
Yeah.
Right, thanks.
So I've had here's kind of my history. Actually, this goes back in some way 15 years. And so when I started at Adaptiva in 2008. I was very influenced by the MIT raw efforts, and Bill Dally, when his paper in 2001 that says route packets, not wires. Before 2008, I was part of a DSP team at Analog Devices that had some gnarly buses that at one point I was in charge of designing, and it was horrible. Buses are horrible. And so fundamentally it was like, we should route packets. Everything is a packet. And 15 years now, everything I've ever done has had to take that approach. So I did, a series of generations of Epiphany chips using these packetized concepts and teams of 3 people. So it's one of those things where simplicity is so powerful. And from a resource understanding and implementation perspective. So I think, those were good data points. 2012, I launched a parallel board and started opening up these things. So there was a fair amount of validation inside FPGAs and in the community as well. Extended it to 64 bits very, very easily from 32 bits without a lot of rework in 2016. And then went to DARPA and managed the CHIPS program there. And we tried to get an open ecosystem working. And I think the lessons from that was AIB was a big success from an opening perspective, right? It had an open source reference implementation, and there was collaboration. Of course, it transitioned to the Navy ship program, and it's had a real impact. And the openness of the spec was a big part of that. Of course, it was only an electrical spec. So my view is it stopped short of what it could have been, but it was still a great thing. So now, and of course, this is the edict, I think, of the ODSA and OCP as well, that open standards work, right? And a bunch of wires definitely work. So let's keep going. So I started the company in 2020 around the idea of 3D chiplets. Said, okay, what are we going to do here? Started with sort of a Epiphany 6 type protocol, but then last year when the team started growing and we had more review, more people looking at it, I would say UMI 0.1 started in mid of last year, and then we did 3 tape outs of UMI in the fall of last year, and then we just did another one a week ago. And I would say that we might be at a 1.0, but I'm careful because it's only internal review so far. So maybe it's less than 1.0, but we're definitely open for review. So next step for us is to open source everything around UMI. It's not far away, and that's when the real commentary can start. So now to the interesting stuff, right? That was just a prelude. So the summary itself, right? So the approach we've taken is everything is a memory transaction, right? And I know there's people who agree with this idea that everything's a memory. So and this has been my view since 2008. So everything's a read write, everything's an address. So in this case, you have hosts initiating requests. It can goes to the network. Gets routed through the network, eventually gets to a device that then responds to the request. And then after that, it's sort of like, okay, details, right? So we can support 64-bit, 32-bit addressing, native word sizes up to 1024 bits, bursting up to 256 words. So these things are, pretty similar to AXI. It's quite compatible. We have native atomic transactions built in. And that's a nice feature. So we can run things like the RISC-V atomic instructions natively through the network, which is pretty neat. We have a link layer built in, and that we can review. And then we have a signaling layer on chip as well, which is just a simple valid ready handshake, very similar to AXI, and it reserves space for future use, right? Which is so important because it's the only way you can really assure backwards compatibility. If you lock in every bit, that you're locked in, right? And you're probably going to break compatibility. So I know this is it looks simple. It is simple. Any questions on the summary?
Love it.
One question for me. Any kind of performance metrics that you could share?
So yeah, I thought about that. I knew somebody's going to ask about that. We can reserve that from when you actually can have the source code to verify it, because if I put up a number for performance, it's always going to depend on implementation traffic. I mean, you're looking at the Which layer, by the way, were you asking?
No, it's Majid from Candu. I just thought, you know, you made a good case for the whole thing, but in terms of evidence, I guess some kind of metric why this is you know, meets that table you had earlier, you know, ticks many more boxes.
Yeah, well, we'll come back with that. It's
Any
yeah.
teaser? Any teaser?
No. I mean, no. I'll put it like this: when we're doing bursting of retransactions or write transactions, you know, we have a command that's a fixed overhead of 32 bits, and so that's the trade-off becomes how the bit packing. So I think that, you know, I think some people will look at the bit packing and see the overhead right away. So we'll but you know, the actual energy and speed is going to depend on implementation. So let me get back to that, okay? So the UMI stack that you know, we constructed here to minimize work and have clean interfaces, which is so important for stacks. So you know, starting from the bottom, right? We have you know, there are lots of PHYs, buses, you know, that we might want to interface with. So we've got you know, a bunch of wires. We've got AIB, UCIe. We have our own 3D C-Link. There are, you know, legacy protocols like TiLink and AXI on chip. And the way we dealt with that, we have this unified signaling layer in the middle, which is basically the transaction with a valid and ready added to it. So it's a latency insensitive channel. And then depending on whether we go directly to you know, an on-chip network like TiLink and AXI, then we just do a bridge to that. Or if we have to go through a PHY, then we have a link layer for, you know, flow control and reliability. And then above the signal layer, it's basically a request and response, sort of without the valid ready. It's just a transaction. So this is how we visualize things. And you know, we've tested this out and verified with AXI, with TiLink, with C-Link, and we've done some initial thought exercises around other PHYs as well, but there's still work to be done there.
So the SUMI on the left is native PHY, basically.
Yep.
Great.
It's yeah, it's a PHY that you would find on chip, right? It's clock reset, a valid ready.
Okay.
Yeah.
That's not a chiplet interface PHY.
No, that's really a I mean, unless you have a lot of wires.
Right. Okay. Thanks.
So how is this adaptation can be done for other people's PHY, like ours? I'm wondering how easy it is to use this in combination with Candu's Quart chiplet.
With other people's PHYs, like
Candu, I just said, like if we wanted to take advantage of what you have here, while we're starting to sort of see how it works with ours, because it's similar to others, but my question is the effort in adapting.
Yeah, I mean, I think it's fairly low because it's, you know, it's a simple protocol, right? It's read, write, address, data, and a 32-bit command packet. You need to figure out a way to translate that into whatever physical interface and signaling interface you have on the PHY. You know, some PHYs might have a I mean, it depends, right? You really have to look at the PHY itself and see what kind of requirements are there.
But effort is not huge. That's what
yeah, impossible to answer that question without knowing what the PHY is.
Because you already say that you have done it for a few compatible. I don't know what it's tested for AXI. You know how much, you know, you could kind of already know gauge the effort.
Yeah, I mean, AXI is not a PHY. It's a sort of it's sort of like an on-chip bus, right?
Right.
I think it's going to be a different cost for PCI Express or UCA as opposed to AXI. But we have experience with AXI TiLink. We actually like going through the implementation phase, and it's modest, but you still need the time, right? So
maybe a different way. This is Kevin. A different way to ask the question is things like Bo and UCI already have a link layer, as does Majid. So it would be natural that people would want to use their own link layer and interface at what you call your signal layer. Does that make a sense as a way to adopt different interfaces you haven't thought of to date?
Yeah, no, that makes perfect sense. If like UCA has its own link layer too, right? If somebody wants to hook up at that level, you just don't use the UMI link layer, right?
That's what I'm thinking. Does that help answer your question, Majid?
Yes. Thanks. Yeah, because
so
in fact, that's to more general, even I'd see between UCIe and bunch of wire, these alternative links, link layers for somebody who wants both of them compatibility. I mean, in theory, in a picture like that, it's easy, but once you see coupling and dependencies, then maybe it's not as easy as originally thought.
Yeah, I'd second that one. It's it's very easy to draw in a diagram. It's it is not necessarily trivial in actual putting it together.
Yep. Yeah. No. And been involved with AIB long enough that I know the challenges. And in terms of the data points we have there, the proof points is we have TiLink, AXI, and C-Link implemented through the stack. And once we release the source code, I think people see that it's pretty elegant or pretty simple. So the summary of the types of messages we have in UMI, we have read requests, write requests, posted writes, and remote DMA request, which is a little bit unusual and somewhat unsafe. And these are initiated by the host. Then we have atomics as well, initiated by the host, and then from the device, right, you send read responses and write responses back to the host. And
Okay.
Oh, hang on, Andreas.
okay, yep.
Sorry, it's a keep going. I'm just going to mute the source of noise. Keep going. My apologies.
All right. So as simple as you can imagine, and the reason why it's so simple in this case is that I'm not showing cache coherency, right? So the number of messages needed and types is pretty small. If you start looking at cache coherency protocols, that the list grows significantly.
Hey, Majid, I'm going to mute you as well. Okay, sorry.
Oh, okay, sorry. I was just taking notes.
Sorry, pardon my ignorance, but what is atomic?
So there would be things like an atomic add. So you would take an address, you read the content of that address, and then you do some operation to it with the incoming data, and usually you send back the original data to the requester. It could be an XOR, sum, a subtract.
Okay, thanks.
So it's an uninterruptible operation, right? An atomic operation on an address. So all the messages, the decode or the opcode or the command code is 32 bits, and this is one of the major design decisions was to have a fairly beefy opcode. And that means that if there's some bits wasted on if you have very narrow transactions, but for wide transactions, it's negligible. And certainly for if you've got long bursts, that goes down even further. So so this is this is definitely a design decision to consider in terms of the efficiency of the protocol. One way of looking at it, like how, what is the minimal number of bits you can compress into? If you look at, if you really want the support and take a bus like Axie, they have all of these wires laid out on various channels, right? Like length, size, protection, quality of service, IDs, right? All those signals are there on an Axie interface. So now looking at some of the command features for those fields, the size, right? 1 through 128 bytes is the native word size. 1 to 256 burst transfers, right, of each of a word size. Atomics, native support, right? This is on an address. So instead of doing just a read or write, you can do an atomic transaction. So full orthogonality there of add, and, or, XOR, max, min, max u, min u, and swap, but not with bursting, right? This is on a single word operation. Quality of service protection, host ID, exclusive access, and then bits reserved for user as pass-throughs.
Andrea, are you going to provide the slides?
Yeah, I can do that. That's not a problem.
Thank you.
So the signal layer, I mentioned it's a valid ready handshake, and basically what we do is we split up the wires into basically the packet, right? We've got a command, destination address, source address, and data, and this is really meant for on chips. So the wires are pretty much free, but beyond that, the topology of the requester and responder stays the same as the UMI, right? It's just kind of digging into more detail for the implementation. And the handshake itself is there's only so many ways you can do a latency insensitive channel. This handshake is very similar to Axie, which is well understood by a lot of people, and so you have a valid transaction when ready and valid are both asserted, right? That's a beat.
Hey, Andres.
Yep.
Sorry, just one question. Last week we had this discussion on UMI being a name overload. If I understand what you're saying correctly, this is not specifically for external memory, but just to treat the entire chip as a memory space and all transactions as memory transactions, right? I'm asking, not asserting.
The view here is that universal means everything's a memory. That's our view.
Yeah, okay. So it's not the sort of more narrow problem of what we were sort of poking around and the idea of how do you access external memory. I'm not complaining. I'm just trying to understand the distinction here. Right?
No, if it was up to me, I would make the whole world addressable.
Fair enough. Okay. But the universal here is treating the SOC as a memory space, not necessarily talking about accessing external DRAM or external HBM, whatever.
Correct. Yeah.
Okay. Thank you. That's so it's a naming collision more than a intent collision.
Yep. Yeah, for sure. Yeah.
Not complaining. Also, just sort of trying to clarify the lay of the land, so to speak.
Yeah. No, that's good. And we're going to have to somehow resolve this, right? But yeah. The reason why I like the name from the beginning was this idea that memory is universal, right? And this is really talking about address data, right? Not about a PHY even, right? It's on chip, off chip. It's It's a transaction. It's a memory transaction, right? It's almost abstracted away. So, but yeah.
So arguably, you could line up the UMI 5 that was talked about last week with your version of UMI here, and still call it UMI, I guess.
I think, yeah, absolutely. That would work.
Yeah,
So the intent collision is with on-die buses. The naming collision is with what we did last week, but the intent collision here is with an alternative way of routing things on and off die.
Yeah, so I mean, so we have this. We have multiple levels of this. UMI. We got, even at the transaction, we have signaling, and then we have FIs, which of course the FIs are never, none of them are called UMI, but you could imagine having a FUMI, right? FI UMI or something like that, right? Instead of the ceiling bow or AIB, right? Something like that.
Yeah. This is a transaction layer memory interface, effectively. Yeah, which you have exactly.
Yep. Exactly. You got it. So at the link layer, with the FI, we want to have some idea of flow control. We need to figure out this serialization across the wires on the FI, and so what is the information order actually packing the things in cycles, right? So for example, if you got an 8-bit interface, right, but we have a much bigger on-chip bus, right, or packet, how do you actually serialize it onto those wires, right? And this is done in the link layer. And so this is we have a credit-based flow control and information order shown there at the bottom.
I'm sorry, just one more. In this case, if you go back to your old diagram, this is the link layer, not as a link layer as we're talking die to die between the two chiplets, but this is the link layer between the source and the target of the memory transaction.
This no, this link layer is this is what sits between the packet and the PHY. So it handles flow control and reliability for the PHY itself, right? So we basically take this.
I see. Okay.
We take this valid ready, because valid ready works. I used to use valid ready off chip as well. So on Epiphany we had a valid ready at the chip level. That was clunky, right? It didn't work very well. So these days, right, if you want to do flow control between chips or even between chiplets, people are using credit-based flow control, right? But we don't want to use credit-based flow control on chip because that's too much overhead.
So it is possible for a transaction to cross multiple links, basically, in the way it's specified. So if you go back to your previous picture, I'm asking again, it's not.
Yeah, I think I'm not sure I understand the question. So maybe.
So, but if you go back to your picture, host, and you had this very simple picture.
Yeah.
No, even before this, like the most basic picture.
Yeah, got it.
Way up front. Yeah. So this network could be, in theory, could be maybe 2 chiplet hops. But the link layer, each one of these would be a link layer, or this is one giant link layer from the host to the device and back.
So this is really showing the transaction, right?
Right.
And so if the host is going to have an ID to it, the device definitely has an address to it, and then the network here is abstracted. It could be multiple links, multiple link layers, as long as information to complete the transaction, right?
Yep. So that link in your picture way down is you could cross multiple instances of that for the transaction to complete, much like an Ethernet.
Yeah, that's right.
Thank you.
And I guess maybe correct me if I'm wrong, but if I understood it correctly, it seems like the link layer, or it's called link UMI here, but the thing that's in purple there could be the ODSA quote unquote transaction and link layer spec, just adapted to the UMI protocol.
Yes, absolutely. I mean, we can. I'll definitely make it a point to update the diagram to show that we can have we can replace our Lumi, right, with
Mhm.
somebody else link layer. That's the whole composable stack here, right? So yeah.
Cool. Okay. Yeah. Great.
So you know, where are we? We have a full specification. You know, we do everything in GitHub, and we keep our code together with the spec. So the RTL is bundled with the spec, which I think is kind of neat. You know, because then you kind of like, that's the truth, right? The repo is the truth. The RTL is the machine readable implementation of the spec. And so if there's any question, you just have that one thing, as opposed to with some other things where you got a PDF somewhere, which is the golden source, but then you got 100 different implementations, and especially in the open source, you don't know, who has bugs and which one's the trusted version. So we have, you know, implemented a bunch of different UMI modules and chips. So we've done 4 tape outs so far using UMI. We've done bridges to AXI and TileLink to verify sort of feature completeness. And we've done this in ASICs, but also in FPGAs, board level FPGAs and AWS F1. So the emulation software that we have up on our webpage right now, that's all using UMI, running on AWS F1 instances. You know, day to day, we use Icarus and Verilator for verification. Also use commercial tools, but this is it's FOSS friendly. So I know this is one of the things that we ran into with EAB, is that you know, you can't run it with open source simulator, which is not great for adoption. So so you know, this is a pretty substantial amount of work that we intend to open source as soon as possible. So really looking forward to that, to see what the feedback is. So we have an example design here that we just taped out a week ago. So it's so I think this is probably the pushing UMI the furthest, because it's a fairly complex system. So it's a quad core RISC-V processor, and you know, Linux capable. And so we basically, and the Linux subsystem here is TileLink based, right? So Chisel and TileLink based, and then we have bridges to hook that up to our UMI crossbar, right? So we have to be able to talk, you know, completely, right? All the memory transactions that are coming off the cache subsystem on TileLink has to be translated correctly, right? Without fail to UMI. And then we bring that out into our main store, right? DRAM or really anywhere, larger memory, and it works, right? We can boot Linux with this, right? So that's a pretty good validation that it works, right? So you know, that this on the right side there, we've got a SUMI based, right, on chip, right, signal lever, valid ready packet, address based crossbar, FIFOs, clock synchronization and everything. And then our C-Link is our 3D chiplet link, which is you know, our one implementation of a chiplet PHY with Lumi implemented, hooking up to the UMI protocol. So and all of this work uses the RTL code that will soon be open sourced for the UMI.
And the TileLink is the only 2D interface you've done for chiplets.
The TileLink?
Yeah.
Yeah. So I mean, so TileLink is that's the Berkeley on-chip cache coherency protocol, right?
Oh, right. Okay.
So it's really like a replacement of AXI or ACE, right? That they use for their RISC-V cores.
Okay.
Hey, but Andreas, so this is pretty damned exciting. The thing I'm sort of not understanding is, don't you also have to standardize an interface into the UMI bus? It's not just the, or is UMI the phrase for the interface in that yeah, this?
So this is the standardized signaling. If you think about an IP block, right, on chip,
Right. Okay.
this would be the interface.
So this UMI, and when you say UMI, you refer to this, not the network is whatever routes the UMI packets, basically.
Yeah. So this is the in this case it would be an on-chip network, right? NOC.
Yeah.
And this is the signaling UMI, right? So this is the raw conductors on chip, right? So so you have a host CPU with this would be the Verilog signal names, right, on the ports.
But you also impose, you have to impose some constraints on the network, saying you will need to route signals with higher priority or something along those lines, right?
In terms of priority, right? So right now, the only requirement is that you have to have two physically separate channels, or request and response.
Right, but there will be at least some requirements saying you will prioritize this class. It's again not a complaint. It's more that you need a minimum spec on the thing that's carrying this interface, so to speak. The carrying packets defined on this interface.
Yeah, so I can say that maybe we can probably talk about that once the full spec is released, because there might be some details here. But in general, the way we implement it, we completely separate our request and response networks.
Got it.
And the top and the bottom, those signals are basically the 32 bits that you talked about earlier. Is that right?
The command, right? So the command is 32 bits, valid is 1 bit, destination address 64 for a 64-bit address map, source address, physical address map. Source address can be 64. That depends on implementation. It can also be less. Data is going to be whatever you decide for your implementation. So just like in AXI, you can make your data buses 64, 128, 512, 1024, right? And then so this is it, right? This is like a super simple pin interface, right, on an IP block.
So the part that's exciting is, if I understand it correctly, and maybe Elad or somebody else can correct me if I'm wrong, the UMI is like a profile on the transaction link layer protocol we've spec'd. So it's nice to have a different set of profiles to aim for. Is that a reasonable understanding?
At least to my understanding, I think it's correct, but maybe I'd state it slightly differently. Of the ODSA link layer could have an interface profile could be defined for the ODSA link layer that would support the UMI as a quote unquote on-die bus. I'm using the term, don't take on-die bus to mean literally on-die bus, just in the same terminology we use in other places.
Could you say that again, Elad?
Yeah, but basically what I was saying was, in the link layer currently, right, there's the concept of interface profile and bus variants underneath that, where the interface profile is just defining what are the protocols that a given link layer is essentially communicating with, and then the quote unquote bus variant is essentially defining which fields and etc. are within that protocol are used in which way, and the combination of the two defines how they're mapped into the specific packet structures of the sort of ODSA link layer. And so what I was saying was that somebody could certainly define an interface profile that would obviously talk to a UMI implementation on two chiplets.
Right. So just a different interface profile definition.
Correct. Yep.
Well, an open interface profile, which is pretty exciting, if all the way around. So on top of being different, if I understand Andreas's licensing terms, it's going to be Apache 2.0 or something, right?
Yep.
Yeah. So that is a nice little twist.
Andreas, what are you using? So I saw at OCP Global Summit your demo with your 2mm tiles all connected together. So what are you using for the chiplet PHYs?
So So if you take the CPU as an example, we have something called C-Link, which is a PHY for 3D connections.
Right, that's what I thought you said.
And so if you look at a BOW or UCIe, it's optimized for 2D connections, right? Side by side chiplets, whether it's advanced
Oh,
package.
so you're assuming your chiplet approach is has a silicon interposer.
Correct, but it's it's active on active, right? So it's 3D. It's not a CoWoS type.
Okay. Okay.
Right. It's
All right.
So you can imagine the distances are very, very short, right? The copper stud is like 25 micron.
Okay.
And so
it's CoWoS based, is it? Or
no, not CoWoS, because CoWoS is not active.
oh, right. Okay.
So the reason why we came up with our own PHY was that when you talk about active to active, the distances goes from millimeters, right, or down to almost nothing, and it is very different from a density perspective to be 3D versus 2D. And
okay, and are you're building the base active tile is one sort of Lego block 2 millimeter by 2 millimeter bunch of interfaces, right? So you use the same active lower layer for all the chiplets on the upper layer, correct?
We have our eFabric, right, which is what is like a breadboard for chiplets, and that's the one that ties all the chiplets together, right?
Okay.
And so you could think of it as you plug think of it as your Ethernet switch.
Okay.
Right. Every chiplet has a little Ethernet cable, RJ45 or something that plugs into something, and then it's like, oh, how do the Ethernet packets get routed, right? And that's the router's responsibility. And in our case,
okay, I got you. Yeah. All right. Okay, that fills the gaps. Thank you.
So a roadmap here over the next weeks, months, years, right, is first of all, open up the specifications and the reference implementation and the translators to really show what's here. The proof is in the pudding. And then, also give more information about our bricks, right, our mechanical standards and our 3D PHYs as well, right, which we will also open up. And then, work with the community to extend it. I think one area that we started looking at, but it's still a lot of work to be done, and there's only so many oceans we can boil. Is look at cache coherence, and of course, there's going to be optimization and integration with other PHYs and protocols and link layers.
So just back on your base die with the switch, that's where you would probably do all of the other interfaces to the various bunch of wires or UCIe or whatever, or even go to the Ethernet or whatever, CXL, etc.
Yeah, so we have we actually made that announcement a couple of weeks ago with our eFabric, right? Our plan of record is to put UCIe on the periphery. So that's our
okay. So that'll be the 2.5D interface. Okay. Yeah. So that's going to be your native, but somebody else could take your. Is that going to be open source? So somebody could take that and then modify those files?
So I'm not committing to open sourcing anything except for UMI at the moment.
Okay. All right. Fair enough.
So I think we'll have to see about that. But we're fundamentally we're a silicon provider, right? That's our goal. So we're not.
I like it. Very, very, very clever. I like it.
Okay. I managed to take up almost the whole hour. Any questions?
I think you brought up OMI in last week's meeting on the UMI PHYs. Would you care to comment on why you asked the question about OMI?
Oh, what? Oh, no. Why? No. It was, just saw similarities between UMI from last week and OMI, right, in terms of the goals. So that's why I asked, and I think it was clarified that it was, OMI was more about off package, right?
Right. Exactly. Well, that's an area where I'd like to explore. That's where that gap between what is off package and what is on package, because at the moment we're all talking half a picojoule per bit and less, and off package we don't care, it's 10 picojoules per bit, and nobody seems to really worry about could we densify at the system level and use 1 or 2 picojoules per bit or something. So I'd like a family of, I'd like us to discuss this world in between on package and off package, because 10 picojoules per bit doesn't cut it when you want to do 5 terabytes per second off package. Now, okay, silicon, the co-packaged optics is going to solve our problems, but let's get real. We could do with something in between the two. And that's where I think that the UMI that was being talked about last week it could be interesting. And I think we should explore that. And maybe this is not an ODSA exploration, but I think it needs to be explored.
Yeah, I agree. I'm bring up one thing that I see a lot in chiplets is seems to be a lot of focus on data center and big iron. I mean, you mentioned terabits. We are kind of coming at it from the bottom, right? Chipletizing the tiny embedded edge devices.
Yeah, and that's a big opportunity. No, absolutely.
So our constraints are different. It's more power constrained. We don't necessarily need terabytes of bandwidth or HPC level memory capacity.
Right.
So I definitely want to. So when we talk about UCAE or CXL or things like that, or HBM, like, well, none of those things are applicable to a sub 1 watt battery operated chip, right?
So with that statement, why did you choose UCIe for your base die then?
Tough call. we have three options basically, right? We have create our own standard, which nobody believes in, right? So that's be a very good reason to do that. There's a bunch of wires in UCA, and right. I think we'll see, but UCA does seem to have a lot of momentum, and UCA in itself is not necessarily that energy inefficient.
Right.
And I think for going off chip, if you're talking about putting a SerDes on in package or a memory interface, the picojoules per bit there is big enough that.
Yeah, but UCIe
should address the comment about the energy per bit. I'd recommend double checking the apples to apples comparison, because it's been stated by a few folks that that's not necessarily the case.
Okay. And UCIe's lowest configuration is 16 gigabytes per second, which doesn't sound IoT bandwidth. I mean, maybe it is to a certain to the high end of IoT, but not the low end.
Yeah. These are very good questions.
In fact, I don't know if Cash is on the call, but Cash has got a little forward one that he's bridging between the two. Well, again, that's another small companies.
So, Andreas, can you go back to your very first slide? You talked about protocol, interface. I think protocol, electrical, and there it is. That's fine. So really, UMI is a protocol. And you have mechanical ideas that you didn't talk about today, which are also quite interesting, but it can work with any electrical layer. You mentioned UCIe, but Bo, from this group's interest, Bo fits right in there. The Bo PHY and link layer could work with your protocol. Thank you. That makes Poppy happy.
Done.
Fair enough. Is that the right way to summarize it?
Yeah.
So you've not talked about UBrick. You've talked about the eBrick approach. I don't think you mentioned UBrick unless I missed it.
He said that's for later on this last slide.
All right. Okay.
He didn't really talk about mechanical much today. It was the focus.
Yeah, I guess what he showcased at OCP is the 3D. So I'm interested in it too.
Yeah, I think that my view on mechanicals is that given how incredibly expensive anything involving silicon is, you need to lock down the footprints like HBM.
Yeah.
And nobody's doing that.
Yeah. Well, you've obviously done that with your 3D that you've showcased. I
Yeah.
think there's opportunity to do it in a 2D in a bit more of a thoughtful way, thinking of the system architecture. Because everything where you guys are talking about in the silicon level, nobody's doing it at the system level. We all say, oh, just chuck it in a 19-inch rack classic server box, where we've got 10 picojoules to go 1 and 18 inches to a drive at one end of the server, or a drive at the other, or a PCI card at the other end of the server. Who cares that we're burning 10 picojoules per bit? And by the way, we need to cableize all of that now, because PCBs are no good anymore for the speeds we're going. So we just need to sort of think about the system, guys, as well. And where you are, that you're fine. But this U-brick, I'd love to get involved in the U-brick. Just thinking beyond the package. That's what I'd say there.
Okay, good. So yeah, more information coming.
Wow, perfect timing. Thank you. That was you got a fairly decent engagement, and I'm excited about the fact that we have this. We have a potential for a new interface profile. Any other questions for Andreas?
I just completely agree. I think the world, the native language of all processors is memory. So this is music to my ears. Well done, Andre.
I figured.
Okay, Andreas, thank you so much. And I know you've settled on UCIe, but if you want to do work on either the a bunch of wires or the transaction link layer, where I don't know whether Kash is online, but we're doing a lot of work on porting Bo downwards. So you're welcome to participate in it, or Zero ASIC, of course.
Yeah, no, I think this is great. I just wanted to add my comments to it. So we look for when. Do you have an estimate, Andreas, when it'll be open sourced? I mean, available for review in detail?
No, soon. That's all I can say.
Okay.
Okay. And then, hey, we had a Die-to-Die 5 workshop on the 16th. Hopefully, either later today or sometime over the weekend, I'll release the slides. And somebody took a bunch of really detailed notes, and Quince released the Zoom link, and I put all of that on the ODSA mailing list. So stay tuned for that sometime today. Okay, thanks all.
Thanks.
It's now Marek's meeting.
Thank you.
Sounds good. Thanks, Bobby.
Hey, Marek, I'm just going to make you the host, right?
Yeah, that sounds good. Thanks. I'll give it one more minute just to see if anybody else comes on or anybody wants to doesn't want to participate here, and then we can start talking about the white paper.
We're back to a unified Zoom link again.
Yes, I know. It's okay. I think people can manage. It may just take longer for Zoom to encode it or something. I feel like the 2-hour meetings just takes longer to actually send out the email afterwards.
Yeah, it has a heart attack. Yeah.
Yeah.
Bobby, you can create 2 different Zoom ID, right?
No, it's a long story, man. Don't even. We will work on it in the new year.
Never mind. I saw you send that, Bobby, like the recording, previous recording, were you able to get the the previous few meetings. I think those some people are missing, asking about those.
Yeah, so it turns out they're not even in a folder. We'll have to it's just one giant, so we'll have to go through day by day. So the problem is you also get spurious recordings when somebody randomly logs in and logs out. So we're looking not just at recordings on the meetings, we're looking at random recordings at all sorts of times. So we'll have to wade through all of those. But it's possible. I mean, you just look for things on Thursdays. Whenever you had the meetings, you just look for the dates. I will see if I can get my hands on that entire folder and get you a link to that.
Okay, appreciate that. Yeah, thanks.
Okay, I think we can get started then. So for this meeting, I wanted to get people's feedback on the entire white papers. I had sent this out to the link to everyone that today we would review, just or that people should have taken the time to just read through the entire document and see if it looks good or if there are any things that we should address. And I know a couple of people had already given feedback last week, so this would be basically any add-on comments from what we had discussed last week. Is there maybe I can just go around and see if individual people have comments. So Boone, do you have any comments? And I can share my screen here to bring this up again.
I don't have any new comments.
Maybe I'll read quite
sorry,
faint.
I don't have a new comment about this one. Maybe I'll try to read again this weekend. If there's any, I was just on drop or not.
Okay, sounds good. But I know you've been repeatedly kind of going through this and added some comments. So I think I've accounted for all of those.
Okay.
James, do you have any feedback?
I think you already marked those, right? The changes I made, I think according to prior comments. Oh, actually, I'm looking at different version here. You have a version 2. I'm looking at that one. This is
Oh yeah. So I had been saving off just for ease of editing. I had been saving off other documents, but I always kept the main link the same. And so that is the one with the most recent changes.
Okay.
Does that make sense?
My comments there, yeah. I think more my comments there, I think whatever that you guys comment, I kind of responded to that. So I think they all should be
yeah. Okay.
good. Yeah.
Okay, perfect. Okay, so then I can clear those. So it looks like this one. Okay. Okay, sounds good. Then I'll excellent. Okay, sounds good. And then about outside of your section, was there anything, or did you have a chance to go through that, or any feedback on this?
I was looking at version 2. Let me look into this version again. Then see anything else I can comment on.
Okay. Next here on my list is Alan. We've been emailing, and you mentioned you had you were able to trim down this section here. Oh, and I guess I don't have you. So that's great. Were you able to read through the other sections or give any feedback there?
Sadly not. Apologies. Yeah, I just updated that as you said.
Okay.
So is that it's about 70% of the original size?
Yes.
So
yeah.
a bit more succinct.
Yeah.
So.
Okay, that's good. Do you think then by next week, to be able to just go through this, and because basically my goal is that we have a fair amount of authors on here. If everybody just signs off on their piece, then ultimately there could still be big gaps where just reading through some other sections would help us just make sure that
Yeah,
we're not
about a
missing.
month ago, I did read through the first half and then didn't finish it. So
Okay, so yeah,
I'll
okay,
take a bunch of it.
got it. Thanks. Anshu, have you been reading, or like have you had a chance to go through the white paper?
So apologies, I haven't had a chance to go through it. I'll go through it hopefully this weekend.
Okay, that would be fantastic.
Sorry about that. Thank you.
No problem. Anu, is that you? Like Anu MCHP?
That would be me.
Okay. New name.
Well, that's because I got a new laptop and I had to
I
reconfigure
see.
everything
Okay.
and I couldn't remember.
Okay.
I think some other Zoom meeting requires me to put name and affiliation, and hence I
I see.
became
Okay.
Anu with the last name of MCHP. So.
Yeah, gotcha. Did you recently go through the white paper, or like I guess you mentioned you read
I had
through it,
already gone
right?
through the previous
Yeah.
version. I didn't go through the new one, but if there are major changes, then I'll definitely try to go through it over the weekend.
No, I think there are no major changes. Or when was the last time that you like kind of went through the entire document?
Not last week, but
The
for
week.
last week's meeting, I had reviewed the
Yeah,
whole document.
that's about the same. So there has I think there have been like a few small changes by Akash and by Rajesh, but that is it.
Okay. Then if you need me to, I'll go through it, Marek, but I think it's in reasonably good condition.
Sounds good. Rajesh, can you comment on where you stand? Like, I know we've been emailing a little bit about this one figure.
Yeah, so actually I have been through the drafts at least 2 times.
Okay.
Looks good, and that's why I just wanted to make sure that my section fits into the overall big paper picture.
Yeah.
So looks like, yeah, and I have emailed you over 2 days ago, right? So
yeah,
I'll make
exactly.
that changes.
Okay.
And then I'll make sure that it fits seamlessly and not just pops up as a standalone. So I would like that section to be integrated into entire flow. That is my goal. Yeah, so
okay,
I understood your comment on organic substrate, because if Trent is there here on call, he can get also some comment. That is fine.
I don't see
Last
him
time
here.
you had asked. Okay, that is fine.
Yeah,
But I think I got your picture. Let me
so
put
this
that.
is about this.
Yeah.
This graphic. Okay.
The picture, and then
Sounds
you
good.
want me to remove that substrate picture, right?
Well, or just like I think it would be like, at least the way I've been seeing it is like if we try to keep this generic, then this could be either like an interposer or a substrate. And so in that case, I think it would be good to just say that it's basically substrate test and then could be interposer or organic laminate. And then not necessarily making it around suggests that it's also a wafer, which it may not be.
Okay. So if is Anu online, right?
Yeah.
You have any comment, Anu, on this?
Sorry,
wafer level?
I didn't review it, but let me look at it now.
Yeah, that's only the picture. I mean, I get what Monaco is saying. So this was a generic picture, but I would like to be as current and as relevant to the current industry as possible, not just some paper.
Yeah.
So if you can.
The one question
is
burn-in done at wafer probe test level, or is it only the net? I just don't know. I don't know enough, hence the question.
No. That is, I mean, substrate test is done at the wafer level anyway, right? That's what I think Marek was saying, that there will be different kind of substrates, organic or so that knowledge base maybe come from your experience, how you manufacture substrates.
Yeah, no, I was referring to the in the diagram, you have the wafer level chiplet test.
Yeah, that one here.
Yeah, you've got wafer probe test.
Yeah, that below is like all the chips on the wafer will be tested tested in a wafer level test. Yeah, that is for when the chips are manufactured on the wafer before the
Okay,
wafer is dissected.
right, yeah.
That's the yeah. That's what.
Yeah.
And then once you dissect, you go to the right side. That is bare die test. That is the bottom. Yeah, and then I
Okay.
think what the question we and Marek has, I mean Marek has suggestion is the second oval on top of the wafer level of yeah, that one.
Yeah.
So maybe this is what I wanted to get input from industrial, how this how the
I th-
substrate is manufactured in the first
Right.
place.
I think that the challenge here, and I think what Mark is saying is because you show a wafer, and it's even more confusing because it says wafer probe test, and below
Yeah.
it says wafer level substrate test. If you just make that a substrate and you can just say silicon interposer, or I would just cover that whole thing up, right? And just put a new rectangle or something and just say interposer test or silicon interposer test, right? The
Okay, okay,
silicon would be
makes
round and
sense, makes sense.
right. So
So
that'd be the easiest way. And
I
and
see,
I
I see.
wouldn't have wafer probe test there. I would just have substrate test. Right?
Yes, yes. So my question
Yeah.
is, substrates currently they do not get manufactured as on a big. They are individual manufactured as not on a big part of the silicon wafer.
Well, the silicon interposers are,
Uh,
but the organic interposers are a panel, I believe, right? So it's rectangular.
okay, yeah, got it. I think I see where the confusion is coming from. Okay.
Right.
Well,
Right.
and then there's the whole side of just the like organic substrates, which are usually built on like bigger strips, but not on wafers.
Oh, okay, okay.
Exactly. So
My
don't show the
yes.
wafer. Yeah. Don't show the wafer there. Show something rectangular and just say substrate.
Okay, I think this is a picture. Maybe it came from sort of when it was not a multi-chip. I mean, not a it in the multi-chip module era when they were doing this kind of stuff. But now the things have changed. Okay, I will work. Mark will work with you.
Okay, excellent.
Now it sounds good. This will because that is the last piece remaining on my side.
Yeah. Okay.
Thanks.
Sure. Yeah. No. Thank you for your feedback.
Yeah.
Then going further, I guess Kashi already unmuted. So have you had a chance to go through the other sections as well?
I scanned it. I think it looks pretty good.
Okay.
So that's just my comments. I think the whole group has done pretty well. So let's ship it.
So actually I have one comment.
Mm-hmm.
And I'm sorry I'm fixated on this diagram that you're sharing right now.
Yeah.
The wafer level chiplet test and the bare die chiplet test, I don't think they're two separate tests actually. I think you probe at wafer level, it's wafer sort, and then do we actually probe at bare die?
I mean, you can. I guess it's.
I think people are figuring out. Obviously, if you're doing super high volume, right, in a closed environment like a microchip, you wouldn't do bare die test because you know what's happened to them. But if you think about the open market, I think people are thinking about how they can test a bare die. Yes.
Wait, bare die test happens today.
Yeah, no. So bare die. So hold on, guys. The bare die test is the same as a wafer level test. It's the die. The wafer.
No, I think there's a distinction between diced die and
we're talking about singulated die,
Singulated
individual die is what we're talking
Right.
about, not
So
die
that doesn't
test.
happen.
I don't know how that happens because, like wafer level, I know happens guaranteed, but singulated die, I don't know about it. So just checking that we actually are correct.
Just Google singulated die test or form factor or one of those big guys, and you'll see that there is bare die test going on.
Okay, as long as, you know.
But in limited, but it's very limited right now. But I think once chiplets are out there and you have this known good die issue, right, where one little die can screw up all the other die if they're bought from different vendors, then I think you'll see this. So I think this is actually a good thing that they've got this in here.
But I think, Anu, you're raising a good point. Like maybe we should put this in as more like kind of have in there like optional or something. Because I think for like a standard like high volume manufacturing flow, my understanding is also that it's not included. But there are certainly, like as Kash said, there are ways to probe singulated die, and you may need to, for example, if you're getting them and you still want to validate before assembly that they're working. And my understanding is that most like probe solutions that you can do at the wafer level, that you can get fixtures that like basically let you do the same test at the bare die level. But it's a question of like when it's being used, and probably you won't be able to step through die as fast as if they were all on a wafer.
Right, it's more expensive, obviously, so a lot of people won't do it. So I think that's a really good point. We should say optional bare die chiplet test, right? So I think that's a good point.
Rajesh, do you think you can include that? If you're saying anything, you're muted.
Yeah, he's on. Rajesh, you're on mute.
Yeah, I was talking on a mute for a while. Okay, so yeah. So my purpose on this is pre-package die test versus post-package when the die itself is going through the packaging. But then if you are assembling it on a big substrate and as a system level system in a package, then you do need to test it, as Kash was saying, that some houses will test it.
It's optional, right? So
Optional,
I think the key
right.
thing is if you, in the line above bare die, if you can just insert optional bare die chiplet test, I think that is the point, right?
Yeah. I think that is good because things which are more current, I will definitely like to see it. Yeah, I'll put that, and then I'll modify the other one Kash was saying that, and Marek was saying that I'll move that to silicon and interposer like changes, and then I'll run through again.
Okay, great.
Okay,
thank you.
That's good. Thanks for the feedback, Anu.
I have one comment here though, right? Since we brought up the non-good dies, right? I don't see that destination here, so I'm just thinking about if you already designated as a non-good die, it means that they already done very good all those kind of like prop tests and wafer sort and everything like that one, right? Can we assume that? I think in that case, maybe like the singulated die can generally be skipped that way. Or if you only for those in general, if you don't tend to like destination as a non-good die, then you have to do that as the bare die testing here.
Non-good die definition has been mentioned earlier in this. It's not in this figure, but it is mentioned per the feedback I got. So it is at the beginning of this section. I have included that.
James, I think the question is, it's known good die on the wafer, right? You test it, it tests fine, right? You saw it up, there is a yield when you break them apart into little die, right? And then they're going to ship it to a distributor, right, somewhere. Then it's going to go to the supply chain. And then now somebody's building a chiplet out of different chiplets, right? So is that a known good die at that point? Do you know where it came from? How do you know? I mean, some people are just going to go assemble it, and then some people, if it's a very expensive product, maybe they'll want to do bare die tests. So I think that's the point, right? I mean, does that?
I see.
Yeah. I think
so. I think that's the. So if we were just trying to show a standard semiconductor flow, this would be not really something worth putting in there. I would tend to agree with that, right? But for chiplets specifically, I think this is actually an important issue.
Yeah, then we'll need to make, just like optional, we need to make that comment in this figure. If that figure, from a KGD perspective, it is already.
Yep.
mentioned in the test, the text portion of it.
I think then, but I like the kind of the suggestion James was giving, because we could maybe then at least on this one arrow that goes to kind of the assembly picture of the die on interposer or package, to put on the arrow like known good die, so that people like also graphically have an understanding of where that term would come in. Like basically like around here for this. Does that make sense?
KGD has been there, for many years, and maybe has to be, whenever you're assembling a package, we assume that whatever die you are getting is KGD, and otherwise the yield is going to be affected at the package level. So it is, showing it on a package, yeah, we can show it since it is already been described the importance of KGD to get the system level package complete, right? Yeah, we can add that.
Okay.
Okay.
Yeah.
All right. So then I'll just go through a couple other people here, just to get their feedback. Hesham, have you been kind of like following this or been able to read through the white paper, or do you have any comments on this? I'll ask you to unmute. Okay, not sure if Hesham is here right now. Otherwise, Jerry, do you have any comments on, like, have you had a chance to look at this white paper in a bit more detail?
No, actually, I'm not really expert on this area, so I just view the paper, but I don't have any comments.
Okay, no problem. And then lastly here, Mitch.
Yeah, I'm just observing and catching up.
Okay.
I haven't been able to attend because it overlaps with another meeting that's not a meeting today.
I see.
But
Okay.
I would
Well,
like the
we're glad
the
to
link.
have you. Do you? I'm not sure like what your interest in this is, but in principle, if you have a bit of time to go through this and basically just leave comments in the document, or just give a thumbs up or thumbs down on certain sections, that would be valuable. And since you haven't been like too plugged in, it may be good, since you're kind of like, you have a fresh eyes looking at all of this.
Sure. Can you share the link? I don't know where to
I'll
get
do
it
that
at this point.
right now. Let me put this in the chat here. Oh, so yeah, you said that before. Sorry, I missed that.
Yeah, no worries.
Okay.
Okay, thank you.
Yeah, no problem. Okay. All right, so then I had a couple other like elements I wanted to go through, which was for references. We had talked a little bit about last time that right now the enumeration is starting at 1 for every section, and obviously like we'll change that for the final document. I wanted to get people's opinions on how like helpful it is to like also have hyperlinks in the text versus just having the references and then having the hyperlinks at the end.
My suggestion, I just went through that, was just commented some of them. I think like maybe it's nice to have that as references to the hyperlink. So that's only my suggestion of preferences.
Okay, you know, I mean, I think that's also would be my preference to like still put the reference, like still put the link or still put the kind of like the brackets and then the reference that people can look up later, but they can also, if they're in the document and they want to jump somewhere, it's easier for them.
And I don't know, Mark, how you're planning, but I've seen like references being put at the end of the page, of the same page, and I thought that's probably more helpful.
So then I guess the main question is like, do we use, like, I assume a lot of people will just use this, like read this document digitally rather than printing it. And if it's digital, do we want to have the links embedded, or I guess if we move it to the end of the page, then again, the question is, so you would say have links, but like have them be at the bottom of the page.
Sorry, I didn't understand. So if they're embedded in the link itself, then that's great.
Okay, yeah, no, I think that would be the like the
Ideal.
option that I think we can do for this document, like basically have links in the document, but also have references. And then at the end, if somebody wants to print the references and go through that, they would be more than welcome to.
Okay, I think I get what you're saying.
Okay.
Yeah. So have a link right here, numbering to the reference down, right? And then reference
exactly.
have the link external. Yeah.
Okay.
Yeah, I think it's probably more clean that way.
Okay. Any other thoughts on this?
Hey, Marek. In order to release a white paper, you need some OCP boilerplate up front. That's on.
Yes, so I did that. I'm like, so I've been reading through this a little bit. I got the templates, and I'll put this on there for next week.
No, you don't need all what you're pointing to. You need the document contribution. That's it.
The multi this like
down,
multi
no, because that involves an IP release. If you go down some more, you see where it says document contribution agreement.
Yeah, this one here, right? The multi-party copy.
Yeah.
Yeah.
Because
exactly. So I was
IP
going to reach out to Michael. So do I basically reach out to Michael and say, like, these are all the authors and we want to have a multi-party copyright license agreement?
Give me 1 second. I can do that. But you also have to put the actual wording into the document itself.
Oh, I see. Okay. I think so I downloaded the template. I'll see if it's already in there, because they have a template for white papers.
Yeah, it's a pain in the neck. For some reason, it doesn't exist for Google Docs.
I think there is in the template. I think if you put that in the template, it should be there.
Yeah. Oh. I already had created one, but I can just pull this up quickly and see if it's there.
And actually, the other thing I don't know is, so there's this thing called the incubation committee that meets on the first Thursday of every month.
Okay.
So that means the next meeting is on December 7th.
Okay.
Or then I'm assuming the one after that will be January 4th. So if you want to release it, so you typically have to sort of make it ready a few weeks before that. So if we want to hit the January 4th meeting, then we would review it with the server group, which meets on the last Wednesday of every month. Except then in December, it might not happen in December. So there's a cadence, basically, is what I'm trying to say.
I see. Okay. Yeah, no, that makes sense. I had been reading through kind of the rules, and I was wondering what IC is, but then I guess that's the incubation committee.
This incubation committee, and so typically you present. So one thing we need to do is present to the ODSA, then the server group in that sequence, and then say, okay, we've presented it, everybody loves it, and then you present to the IC, which then becomes a thumbs up, thumbs down.
Gotcha.
And, and so the server group meets on the 4th Wednesday of every month, except I think there is no meeting in December, if I'm not mistaken. So I'm assuming there will be a November meeting on the 29th.
Okay.
Wait, the 4th Wednesday will be 22nd. Sorry. So that'll be, so one option we could do is just talk about this white paper and say we're putting this together on Wednesday, the 22nd.
And so if we do that, then we have to like catch the following IC meeting.
No, not really. No.
Oh, okay, great. So there can also be like delays in between.
Yeah. This is simply to say we're doing this. We value your opinion, and here's the link if you want to make any suggestions.
Okay. Yeah. No, I mean that sounds. That is what day of the month? That's just before Thanksgiving, right?
Yeah.
Okay.
I think I'll find out as soon as I find out when it is. I'll say this is what we want to present, and and if you're ready, and then we can do.
Yeah, I guess it's the when like it's right before Thanksgiving, so I'm not sure like if the meeting happens, like I'd be happy to like try and get in there. Because I guess otherwise it would be at the end of January then.
It would likely, yeah. Let me find out, and I'll find out what the schedule is and get back to you. And
okay, sounds good.
Then maybe on December 8th. Let me just check the schedule right now. On December 8th, maybe we just present this to the ODSA, the entire white paper.
Mm-hmm.
Because it seems reasonably complete now, right?
Yeah, I think so.
So December 15th, it's Samsung. Oh, wait, December 1st is the one that's slowed. 8th is IIT Bombay. 15th is Yan Lee from Samsung, and or we go early in the new year. It's your choice, whichever works. So we can either go 12/1 or Jan 5th.
Okay.
So pick. It seems like we're not going to make the December IC meeting anyway. Just the Jan 5th is after the January IC meeting. Okay. Let me find out. So we'll find out when the IC meets in January and December, and we'll find out when the server group meets over the next 3 months.
Okay. Yeah. No, that would be perfect, and then we can align the schedule to that.
Yeah. So it's either the 1.5 or 12/1 are the slots. I think we enroll with the 1.5. I think we just, even if we go to the IC on the previous day, we say we're presenting to the ODSA tomorrow, and so we'll incorporate any feedback we get. I don't see that as a major issue.
Yeah. Okay. Sounds good.
But
then let's aim for that.
Keep those dates in mind, basically, roughly.
Yeah. Oh wait, I'm out on vacation still. I think on the 5th.
Okay, so then the other option is just to roll this whole thing into January and go 119 for this.
Okay, I would certainly be around for that.
Okay, so let's make 119. So then we can definitely make the February IC meeting. So let's just settle on that, and right. So we target the February IC meeting 119 for this. 119, and then the server group meeting will likely be on 124. So the timing should work out beautifully.
Okay, so then they're all like pretty consolidated. Okay.
Yeah. 119, 124, and 2.1 is my guess. 2.1 or 2.8.
Okay. Yeah, that seems to line pretty well.
All right. Sold.
Okay, thanks. All right, yeah. So it looks like in the template here that I downloaded, they have the section on compliance with ODSA project tenants. So I think there's I assume that's kind of the verbiage that you were referring to, Bobby.
Yes. There's something. Yeah, exactly. Yes.
Yeah, and then there's a license. Yeah, there's also the license at the end.
Exactly.
Okay, perfect. Yeah, so I'll paste that all into here to make sure that we have the same look and all the required text in there as well.
Yes.
And it looks like they have a smaller font, so that may help us. Okay, so then that's helpful. The other thing I just wanted to go through with people is the images that we have, and basically where we need to, I would ask whoever put an image into either make sure that we have it that it's owned by your company, or that we redraw it or ask for permission. So I think this one here, Bobby, we had talked about this before, and I was going to take a stab at redrawing this so that it looks a little cleaner and that there's no issue with copyrights, right?
Wait, this is mine.
Yeah, exactly. This is yours.
Yes, there's no issues with copyright. I think I sent you the original file too, right?
Yes, I have the slides that this came from.
Yeah, okay.
I think in the slides, though, it may actually be, I'll check if in the slides it's the actual drawing or if it's just another.
Yeah, so somewhere I have the original. Do you want just this wheel without any of the text, or you want to redraw the wheel too?
I thought the text was kind of helpful, but I think that one I was going to put into draw that in slides and then make sure that we I assume at some point we want to have kind of a vector graphic version of this so that we can make
okay, let me know what you want. I know I have the original somewhere. I'm happy to give it to you.
Okay, all right. Yeah, no, that would be good. Okay, so then that is discussed. I think here for this one,
That is really important what you just said. If you included a figure that you don't own or isn't in the open, we absolutely have to redraw it. It took me an eternity to redraw that picture.
okay.
So that's vital. We get dinged really badly. We can't sort of do copyright release on something we don't own.
Yeah. Oh yeah, no, then of course, because we're claiming that it's now suddenly Creative Commons, and if
Yes.
it wasn't there to begin with, then that's a pretty egregious.
Yeah, it's like, you know, we're giving other people's property away, not ours.
Yeah. Okay. I think this one here is easy to redraw. Like Anu had put this in. I think she's not on anymore, but like that I don't think is hard. This one here, thanks James for adding the comments and making sure that we have everything labeled. I think this one we would need like probably, or maybe we also just want to redraw like a simpler version of this rather than specifically pointing to like the vertex product there. Let's see. So then I'll probably check in with Trent since he's not online. Like he has referenced where these pictures are coming from, but I think he would just need to ask for permission for this one. The table also, this one, like he has a fair amount of pictures. This one I drew, so I think that's fine. And this one I think we also he created himself, so that should be okay. And then Rajesh, for this picture here, do you think you could get like whichever paper or so you found this from, just to reach out to the owners and ask if we can reuse that as is, or otherwise
yeah. I think if you see, that's exactly the question I had asked in the first time I used this figure, and as Bapi said, I don't mind drawing this again, because this is very specifically coming from the IEEE publication, which I have referenced in the figure number 1, right?
Yes.
It is from, so first of all, the authors are from Synopsys and the IEEE standards chairman for that 1838. So both are publicly published this in the IEEE computer magazine.
Yeah.
But,
No, but
and that has been the reference. So I don't think we can take any chance. I have to redraw this, right?
Yeah, well, you can ask them for permission, Rajesh.
Yeah.
Oh, I can send the email then to.
Yes. Yeah, and I think, especially for something like IEEE, I think it's pretty standard. Like I don't know anymore where exactly the form is, but they often have for journals like even a section where you can just say like ask for permission, and you say basically the article number that you and what specifically you want to cite and for what purpose, and then they usually get back to you within a day.
Let me let me send the email to because if you look at the reference number 1, I can send the email. That's why actually very specifically in an article from magazine, I've just take that picture. I mean, I'll try that.
Wait, just so we're clear, right? I think most people will give you copyright to use it, permission to use it in your document, but we have to be very clear and say we're also releasing the new document under Creative Commons.
Correct. So I think in drawing this picture, because this is just a replication of also what is published in standards, right? This picture is from magazine, but it's based on the IEEE 1838 standard, which is another copyrighted standard. So I can draw the picture again and give the reference there, as you mentioned.
Yeah, I guess if that's not too much hassle, I think that's certainly like a safe option to do. Because then we're kind of in control, and you know that it's fine.
I don't want to just just take the picture just to reduce the effort, but I'll redraw it and see. It's based on the IEEE standard as well as the reference I gave.
Yeah.
Okay, I think that is better, just to avoid any consequences.
Yes. Yeah. Okay. Sounds good. I like that. And then this one here, I was going to just use the link and put it into the text rather than having that, but that's an OCP paper, so that is not a problem. This one you drew yourself, so that's good too. This one I created, so that's fine. This one I like Irina had created, so that should be fine too. This one here I have to redraw, but that's not a problem. Like that's easy to do. And then Kash, I assume we have permission to use like this one here.
Yeah, that's mine. So
yeah. Okay. All right. Okay, so I think those were all the images. And then yeah, so I think then the last thing was at the meeting last week, we Bapi brought up the idea of finding others to help review this document, like people that you may like colleagues that you may have in your company or something. I've reached out to a couple people with an ADI and asked them if they could also review this. Does anyone has anyone reached out to somebody else that could give us input? And if not, then if you know anybody, I think that would be great to do.
Sorry, Marek, I missed the last the earlier 10 seconds. You're looking for input from non OCP people?
Yeah, basically, yeah, like people ultimately I think the goal was to think about like do a little bit of audience testing. So if you know anybody that is like basically like a product manager or like a system architect, the kinds of people that we're trying to write this paper for, and if we can get feedback from those people and say this and that I don't understand it all, then it's a good chance for us to make some changes before we release it.
Yeah. Yeah, there is a subgroup like my friends call it like the Indian mafia. I'm just partly kidding, but there are a bunch of architects that from different companies. If it's okay, I'll share it with, and Dharmesh is even part of OCP, I think Dharmesh Jani. But I can share with a couple of people and get them get their feedback.
Yeah, I think that would be good. Bapi, do you think there's any like issue with sharing with like non-OCP people?
No, not at all. Considering we're going to open it up. So yes.
Yeah, perfect. Okay. Thank you, Anshu.
Sure.
Okay. Those were all the things that I wanted to go through today. And any other comments, thoughts?
Marek, I have a question. When you said the references will be in line, are you going to put numbers or the title of the article as a hyperlink?
So no, so my thinking was to do both, like whenever it's a hyperlink, to do both, to like put a link into the text, but then at the end still have a bracket and say number like 16, and then you can go to the references section, and in number 16 you can check when we retrieve the information, where it was from, and so on. And if it's a paper, then it would just be the typical paper citation text.
Okay.
Okay. All right. If there are no other questions, then I think we can end a little bit early, and have a good Friday, everyone, and a good weekend.
Excellent.
Thank you.
Thanks, Marek. All the hard work, man. It's coming. It's coming to.
Yeah, it's good to see it moving forward and us talking about actually releasing it. So that's nice.
Yeah. All right.
All right. Okay. Bye, everyone.
Bye-bye.